All right, let's dive right in. Today, we're talking about a brand new discovery that has scientists, well, scrambling to rewrite their cosmic cookbooks. It turns out the James Webb Space Telescope found something that's seriously challenging what we thought we knew about how planets, especially rocky ones like Earth, are born. So let's just ask the big question right up front. How are planets really born? For decades, we've had this standard recipe, a model that seemed to check all the boxes. But what if that recipe is missing a key ingredient? Or maybe it's just plain wrong for most of the universe?
And this is where it gets really fun. JWST has peered into this planetary nursery and found a baby star with a planet-forming disk that just doesn't fit the mold. At all. It's a total cosmic curveball, and it's forcing a major rethink of the entire process.
To get to the bottom of this, we've got to go right to the source. So let's head to a very strange cosmic nursery, where astronomers have zoomed in on one particular infant star. Its name is XUE10. So here's its cosmic address. XUE10 isn't hanging out in some quiet suburban part of the galaxy. Nope, it's about 5,500 light-years away in this massive, chaotic, and incredibly intense star-forming region called NGC 6357. And trust me, its location is the key to this whole mystery.
Right, so that chaotic location is exactly where the plot thickens. Because what JWST found there just shatters the established rules of planet formation. Let's break down what we thought we knew versus what we actually found.
Okay, first, just so we're all on the same page, when we talk about a planetary nursery, what we really mean is a protoplanetary disk. Picture this giant, spinning pancake of gas and dust that's left over from a star's birth. This is the raw material, the cosmic clay that planets are made from. So, up until now, the standard recipe went something like this. Way out in the cold, outer part of the disk, little pebbles loaded with water ice start to form. Then these icy pebbles drift inward, getting closer and closer to the warm central star. As they heat up, that ice turns directly into a gas, releasing a ton of water vapor right into the zone where rocky planets are supposed to be forming. Makes sense, right? And this is where it all falls apart. Based on that recipe, astronomers were expecting to see a huge signal of water vapor in the inner part of XUE10's disk. But what they actually found was, well, the complete opposite. The water was almost gone, and in its place, a shockingly high amount of carbon dioxide. The ingredients are just all wrong. And hey, you don't have to take my word for it. Jenny Frediani, one of the researchers from Stockholm University, said it perfectly. She said, quote, "Water is so scarce in this system that it's barely detectable, a dramatic contrast to what we typically observe. So we're not talking about a small error here. This is a massive contradiction." So this brings us to the investigation. If the recipe's all wrong, something must be messing with the kitchen. We're now in a case of extreme radiation, and we're about to find our prime suspect. The big question is, what on Earth, or, off Earth, could be powerful enough to completely rewrite the chemistry of an entire developing solar system? Well, the answer isn't the star itself. It's the neighborhood it grew up in. The culprit is hiding back in that cosmic address. You see, NGC 6357 isn't just any old star-forming region. It's what's called an extreme ultraviolet environment, or XUE for short. It's absolutely packed with huge, hot, young stars that are just blasting the whole area with unbelievably intense radiation. It is a very, very harsh place to be a baby star. So here's the leading hypothesis. This constant, relentless bath of ultraviolet radiation from the giant neighboring stars is essentially baking the protoplanetary disk of little XUE10. This intense energy is fundamentally changing its chemistry, destroying certain molecules like water and allowing others like carbon dioxide to thrive, all before the planets even get a chance to start forming. As another researcher, Arjun Bick, points out, finding so much carbon dioxide is just so unexpected that it points a giant finger directly at this idea that the intense UV radiation is the real culprit here, actively reshaping the ingredients for future planets. Okay, so we found a weird star system getting blasted by its neighbors. Big deal, right? Well, this is why this one little star matters so much. We're now talking about rewriting the entire cosmic playbook and why this discovery has huge implications for all of us. And here it is. This is the piece that makes this so incredibly important. The environment around ZUA-10, this intense, chaotic, radiation-filled nursery, it's not a weird one-off. It's the norm. Scientists believe that most stars, and by extension, most planets, are born in these crazy high-radiation regions just like NGC 6357. Our own sun was probably born in a similar kind of cluster.
This has absolutely massive implications. I mean, it doesn't just challenge our old models. It suggests that the kinds of atmospheres planets can have might be way more diverse than we ever imagined. And of course, that directly impacts a planet's potential for being habitable. And get this, it could even help explain some weird chemical fingerprints we see in meteorites right here in our own solar system, hinting at the fiery childhood of our sun. The team leader, Maria Claudia Ramirez Tanis, really sums it all up best. She says that understanding these effects isn't just some abstract science problem. It's absolutely essential if we want to grasp the true diversity of world out there, and ultimately, figure out which ones might actually be able to support life. So in the end, we're left with this really profound thought. The JWST has shown us that the recipe for making planets isn't one size fits all. It's this incredibly complex thing that can be totally transformed by the environment. And that just leads to the biggest question of all. If the playbook for something as fundamental as making a planet can be this varied, what else don't we know?